is number 4. We're still in the thermochemistry summary part. So towards the back of your packet where you have those 8 problems in part 9S. So we're on number 4. Number 4 says the standard enthalpy of formation of BrCl gas is 14.7 kilojoules per mole. The standard enthalpies for the atomization of bromine liquid and chlorine gas are 112 and 121 kilojoules per mole of atoms respectively. Per mole of atoms, okay. Calculate the average enthalpy of the BrCl bond in BrCl gas. So we know our goal. Our goal is to figure out if we take Br bonded to Cl, and that's in the gaseous form. I just drew the bond because I wanted to accentuate that we're breaking that bond. And the only thing we're doing is we're breaking that bond. So we're not going to form any new bonds, we're not going to form any new attractions, we're just going to take the Br. It's going to be strangely alone, not Br2 as it usually exists, diatomic. And the chlorine is also going to be alone. So the question is, what is the change of enthalpy for that? We're going to use the other steps to add up to that. So I'll write the steps that I have down here, and then we can, actually I'm going to show a small shortcut. Yes. No, I'm not going to do that. Okay, let's see. So we have the standard enthalpy formation of BrCl. So what I'm going to say with that is that step is going to show me the formation of BrCl. And these states really matter because you can see that we have some change of state steps here too. Since it's standard formation, I'm forming 1 mole from the elements as they exist. So they're both diatomic, off crinkle. This is a liquid, this is a gas, and since it's formation, I'm going to form this 1 mole. That means I'm only going to need half a mole of this, half a mole of that, and I get the change of enthalpy is 14.7. So 14.7 kilojoules per mole. That's that step. Then another step I have, if I make, this is the thing I didn't notice in class, if I'm going to make a mole of atoms from bromine liquid, I'll have a change of enthalpy of that. So that means I'm starting with bromine liquid, Br2, as a liquid. I'm making 1 mole, just 1 mole, of bromine atoms. So it's got to be a gas, otherwise they'd be stuck together. And we couldn't just say that they were atoms. So that means I need half of a mole of the bromine. This is what I did not do in class. I didn't realize I was making just a mole of atoms. Okay, so that's going to be 112 kilojoules per mole. And I'm also going to make 1 mole of the chlorine atoms, so I'm making chlorine CO as a gas, because they're individual atoms. So I'm just going to need half a mole of Cl2. Okay, so that's the atomization of the bromine and the chlorine, making 1 mole of bromine, 1 mole of chlorine, and that one's going to be 121.0 kilojoules per mole. All right, so I've got my steps. I can flip them around and do what I need to do to make sure they add up to the overall. So I can see that I need to start with this as a gas. The only place that it shows up is here as a product, so I'm going to flip that step. So I have BrCl as a gas being broken down to half a mole of Br2 as a liquid and half a mole of chlorine Cl2 as a gas. Okay, so I just took this one and I flipped it, so I'm going to take this positive 14.7 that I was given and flip the sign. So it'll be a negative 14.7 kilojoules per mole. All right, and then I know I want to form 1 mole of bromine gas. That's happening right there. So I'm forming 1 mole of Br as a gas, and I'm starting with 1/2 of Br as a liquid, Br2 as a liquid, and I can see the change there is that 112 because I just took that step and wrote it in the same order. 112 kilojoules per mole. Okay, and that last step I can also just take and say, I need chlorine as a gas, just 1 mole, so I'll take this step, put it right here, take half a mole of Cl2. as a gas, forming 1 mole of Cl as a gas. And I can just take that and put it right up here. 120, oops, that's a 2, 1 kilojoules per mole. And now I want to make sure that these steps really do add up to the overall reaction, plus I really want to cancel stuff out, because you know that brings me joy. Great joy. Okay, so I have half a mole of bromine liquid here and here. Got half a mole of chlorine gas here, Cl2 gas, and here. So overall, I can see what's happening is I have this bonded BrCl in the gaseous form, and that bond's being broken to turn it into just an atom of bromine by itself, it's a gas, and an atom of chlorine by itself. Okay, so all I did is I broke the bonds. I can't put Br2 or Cl2 there because then I would be forming new bonds and I wouldn't just have the change of enthalpy of breaking that one bond. So now when I add these all up, I'm going to get 218 when I round to the nearest whole one because I only knew these answers to the one. So 218 kilojoules per mole. And if you're wondering if it's positive or negative, well, if you're going to break 1 mole of these bonds, I'm going to add. So I have to put in energy to separate those attracted things to make them less stable. If they come together, they're becoming more stable, and they're giving off 218 kilojoules for every mole of those bonds that I form from those guys.